What's happening, everybody? Welcome to the Mineral Lab, which you could probably argue is maybe the hardest, maybe the silliest one to try to do online, but hey, we're almost done. So let's try it out, see how it goes, and then we'll get you out of here. And thanks for the patience. I know that it was a little frustrating going to online this year. Most of us have done well. So this is our mineral drawer. It'll look slightly different because this is just in Windows. Yours is uploaded into Brightspace there. Should go by those numbers. I've got them programmed in over here, and I'm going to write a couple things here because some of this is just impossible to do. There's no way you're going to do a hardness test with a picture, right? But we should mention what it is because that's the job here, right? So I'm going to have you define these. Let's look through them quick. Luster is essentially the way that a mineral reflects light. It's not color. That's a different idea. It's when you hold it in the light, how does it shine? The first one, like the main category people usually go to is whether it's metallic or non-metallic. But then you can also be more descriptive from there with other words, which can really be very obvious words like this. Shiny, like it shines like glass. That's not metallic. That's different than something that like looks like metal when it reflects light. Like this guy looks a little bit more metally. That's a metallic luster. This one is more glassy or shiny, right? So what does it look like, again, from a picture, the best you can, how does it look like it reflects light when that light bounces off of it? Hardness is its resistance to scratching. How much does it resist scratching by other minerals, essentially? There's a scale, you know what, and we're going to put that scale right into your lab here. Let's pause. All right, we're back. I stole the one from the textbook. If you're in my 100 class, the online textbook, what we'll worry about here is the scale from 1 to 10. They're not like quartz doesn't have a hardness of 7 somethings. There's no unit on it. It's a relative hardness on the scale developed by Mr. Mose. And then, yes, you can quantify this, but we're not going to worry about that necessarily. But you can also maybe notice that it's not a linear scale. Okay, all of that. It's resistance to scratching. So if we were in a mineral lab, what you would do is you pick up, like if you picked up number 34 here and you picked up number 29 here, it's very obvious when you try to scratch them on each other, number 29 would get very scratched. Number 34, nothing, because 34 is more resistant to scratching. It's a harder mineral than number 29. So you can't do that with a picture. So what I'll do is I'll plug those in here so that you can base some of your work on that. What else we got? Breakage. If the mineral breaks, what does that look like? You got two options, cleavage or fracture. And you don't have to define like that. It's just to say that cleavage and fracture are the things. So cleavage is when it breaks along predefined repeated planes. The easiest example of cleavage is number 32 here. Parallel planes in a mineral, which you've got a couple sets of here. This one looks like a parallelogram. You've got this one parallel with this one. You've got this one parallel with this one. Then you've got the top facing us parallel with the bottom down on the piece of paper, right? When you see these repeated faces, it's a pretty good indication that when this breaks, it likes to break along those predefined planes. Fracture is going to be when it's just kind of all jumbled up. I guess that might even, and it gets tricky. I guess you might try to argue that some of that looks parallel with that. But let's do a better one for fracture. You might have a lot of cleavage ones on here. All right. Nothing is really repeating. Now, where it does get confusing is with what's called the crystal habits. The way that when this mineral formed, the way that the little atoms like to grab each other in the environment that it formed in and form a larger and larger and larger piece may make it look like cleavage. And number 34 is like the famously screwed up one that students mess up all the time when you're learning this, because you're going to say, hey, parallel, or not parallel, but you're going to say, oh, flat faces over and over again. That's actually the way that crystal grew. They don't repeat. They're not parallel. And if I took this and I bashed it with a rock hammer, it wouldn't break along those planes in multiple directions. Why don't I actually grab some minerals? And And I'll gamble here that these will show up well on camera. We'll see. So I'd say fracture on that. Nothing seems to be repeating over and over and over again. Fracture on that. Nothing seems to be repeating over and over again. But this is where we'll get into talking about cleavage. That's that parallelogram one. That's a similar sample to what you have for number 32. And if you were able to look really close, I don't think the camera's going to pick it up. You can see within it that there's little lines that end up parallel to that face. Here's your one that's like number 34. So again, yeah, there's flat faces, but that's a crystal habit. You can see where it broke right here. It's just jagged and smashed up. Same on the other side. All right. It'll be a little harder. Do your best to try to figure them out. We'll see how it goes. Streak. What streak is you use a ceramic plate. What it is, how to define it, is the color of a mineral when it's powdered. So what you do is you use this ceramic plates. Now they almost feel smooth, but they're very finely porous. And when you scratch a mineral on it, it leaves behind the powder of the mineral. Not always. If it's a very hard mineral, it's not going to work. Some minerals don't have a streak. Having white and black plates is a good idea, because if it's a white streak on a white plate, sometimes you can't see it, but you don't have either. So again, that's going to be somewhere where I'm going to have to help you out to, I didn't even put it on here. That's why I didn't put it on there, because you can't do it. All right. So what are you going to do? So I'll have you figure out lusters. Hardnesses, I'll go ahead and plug in right here without, I won't talk through it so I don't waste too much of your time on a video. Breakage, that's where you're going to try to figure it out. Is it cleavage or fracture? Any special notes, anything that looks kind of unique? Both 27 and 29, and you can add to this as well. I'm going to add it right in. Feel kind of greasy and slick. All right, again, the camera's not going to do anything for you here, but I'm stubborn. I'm going to put it up here anyway. When I like rub this with my thumb, it feels really like smooth and slick and greasy. And then there's the other one you have, same thing. Like, I mean, it can almost like slip right out of your hands. In fact, it's used as a lubricant if it's powdered. That one right there. Sorry, I lost the other window. Lost it entirely. All right. So yeah, 27 and 29 have a greasy feel. 28 might look like gold. It's not gold. You'd have to be a fool to think it is. 30 and 31 are very cool. These are called sheet silicates. They're the way that this cleavage forms. I'll give it away. It's cleavage. Is that they're silicates. They like to, the things that are in them, the silica and the oxygen, are very efficient at grabbing each other out in sheets, but not very good on going up. So you get like sheet after sheet after sheet of them. They're harder to break apart that way, but they're very easy to break apart this way. So they get flexy and thin, and you can like pull off a thin sheet, pull off a thin sheet, pull off a thin sheet. It's satisfying if you feel like breaking all the minerals. And there's the darker one right there. Same idea. So 30 and 31. Get my stupid head out of the way. All right, 32 has this double refraction thing. Now, the table I gave you doesn't mention that. But what this is a property of this mineral where it's the way that it optically treats light is that the light can come in and then get split into two beams and go through. So I stole this picture from the internet, but if the text looks like this when it comes through, because of that double refraction idea, it gets split. It's pretty neat. This is a piece of it here, but it's not clear enough to actually do that. The other big giveaway, though, is that if I had a little bit of weak hydrochloric acid and I dribbled it on there, it's bubbles. So this one bubbles in acid, which is a major giveaway, makes it very easy. We didn't talk about that when we talked about limestone, so there's another hint. It's the stuff that makes up limestone. Use your little table, and figure it out. 33, 34, and 35, we're getting into the much harder minerals. So these are all, when you do hardness, really, if we were doing it in the lab, what you tend to use is a piece of glass, a little tiny square of glass, and you try to scratch a mineral. Or your fingernail. If the glass comes in at about 5.5, your fingernails come in at about 2.5. So 33, 34, and 35 are all pretty hard. That's not what I want to do. So we'll say greater than 5.5 for all of them. All right, then you can go by the color a little bit off that sheet and go by what the crystal looks like. Color is one of the ones in minerals that's not super helpful in general. It can occasionally be a bit of a giveaway. It can occasionally get you there when you start to get it down to a certain section. You got it down to a couple. What could it be? But if you think about it, lots of minerals are like clearish to white. It's not a very good distinguishing thing. Or this mineral number 34 here again, the image I use is a very clear one, but there's a white version that's kind of milky. There's a smoky, there's pink, there's purple, there's all kinds of different colors. So the color wouldn't be a good distinguishing characteristic for that, but maybe you can use it a little bit here with what you see in the table that I included in these segments and in the lab week, and we'll see how that goes. All right. I'm hoping that's enough hints to get you there. If not, of course, feel free to email me anytime. We'll see how it goes. The chemical formulas are all taken right from that table, and we'll go hint, because I know this is a pain, that this isn't the answer. I'll do water. How about that? You know how you got to do the little subscripts? If you do control, hold down control, and the comma, it goes down to, one moment. So yeah, control with the comma, it goes to like subscript, and you can do two, and control with the comma again. Oh, that'll help. I know that's a pain to do that in typing. It's much easier to write it. And if you're on a Mac, it's that little, I've got no idea what the name of the symbol is. It looks like the hashtag thing, but they're like rounded. I don't know. Hopefully that helps fill those in for the chemical formulas. Again, they're right on there. It's just writing it in, and we'll be good. Then we'll pop over to a quick quiz where you use the table a little bit, and then stay tuned. I'll do another video for how we're going to wrap this course up. Thanks, everybody. Good luck with this one. We'll see you soon.